guys, if you're watching the mailbag section, you will have seen that a company called icstations.com sent us a number of products to review. You should have a look on the IC Stations website. They have a great selection of electronic components, a lot of which would be very useful for making your RC tractors or any of your other electronics products. So the first product we're going to have a look at here is this joystick. Now, the link to the joystick will be in the description below, so check that out if you want to see. And basically, it's a joystick from like a PlayStation controller or an Xbox controller. And how it works is we have two potentiometers here. When you turn the axis, you can see the potentiometer is changed, and from our electronics theory we can work out what position that potentiometer is in at any one moment. And we have a switch on this side, so when you push in the joystick you activate the switch. So I'll hook up the multimeter and we'll have a look at the resistances. So let's have a look at the resistances. If you look at the potentiometer, we have 3 pins here, so 1, 2, 3, and if we take the 2 outside pins we should get the total resistance. So we can see that's around about 4.6k potentiometer. We'll just check the other one, it should be the same. Yeah, so around 4.6k. Now, when we adjust the joystick here, so if I change this axis, you'll see it spinning. The resistance between here and here, and here and here will change. So I'll flick to the other leads. So now what I've done is I connected the multimeter lead to one of the outside pins and the center pin. So now when we adjust the potentiometer, we see the resistance is changing. Okay, so if we consider that we're going to put ground on one side of the potentiometer and the positive 5 volts on the other side, then the center pin will give us a voltage that will vary, and that's because of our theory. And this is literally a back of the envelope calculation here. So we say Vn is going to be one side of the variable resistor, so that'll be our 5 volts. The other side is going to be ground. This is this central portion here, the V out, would be the central pin of the variable resistor, and this is the variable resistors, or this is the resistance that is going to vary. So one of these is going to get smaller and the other is going to get bigger as you move the joystick back and forward along this axis. Our equation we have up here, so this V out from our potentiometer is going to be the voltage that we inputted, so our 5 volts multiplied by the resistance of this lower resistor over the sum of the two resistors. Now from that we are able to calculate the position of the joystick, and we'll use that later on when we are controlling or using this joystick to control our Arduino. If we look back at our pins on our joystick here, the first pin here is ground, then we have the 5 volts, we have the voltage from the x-axis, voltage from the y-axis, and the switch. So we've only 2, so basically they've already wired the ground to each potentiometer and the 5 volts to each potentiometer, so you don't have to do that. And what we're getting at here is going to be the voltage, which varies as the X or the Y axis is adjusted. The final thing we need to look at is the switch, and to understand how the switch is set up. It's important to know how the switch is set up because normally when you are working with your Arduino, you put your switch in one of two configurations. So you either have it normally grounded, so normally 0 volts, and when you flick the switch the signal goes high, or you have it normally high, and when you flick the switch the signal goes low. Now we aren't wiring the switch in this case, it's already been wired, so that's why it's important to understand. You can't, it's already wired to ground, and you try to do this configuration. You're just ground and ground, the signal is never going to go high, so that's why it's important to figure it out. So to do that, we set our multimeter to the diode symbol here, and we choose 2 pins. So it's either going to be ground or 5 volts and the switch pin. So it's either ground, 5 volts or the switch pin. So now I have the ground 5 volts, and if this is right, we should get a short circuit on the multimeter. Yeah, okay. So now we know that the switch is closing the circuit to ground. Now there's no resistor going to 5 volts here, so this is this configuration. You have to use this configuration, and you'll have to put a 5 or a resistor of your choosing, I suppose, but usually a fairly big resistor between 5 volts and this signal wire then to ground. So you go 5 volts to resistor, the signal to the multimeter, and then through the switch it goes to ground. When you close the signal, your signal goes from high to low. So it's normally high system that you need to set up for your Arduino. One thing to note about the switch on this joystick, if you intend to use it with an Arduino or possibly many other microcontrollers, is that the Arduinos usually have internal pull-up resistors. So if you enable internal pull-ups on your or in your Arduino code, then you are effectively including the resistor on the switch. So you don't need to physically include a resistor, because you're using the resistor that is internally built into the Arduino. So that will remove a step. That might not be possible with every microcontroller, so I'm going to include the resistor in the videos just for the example, so that you see where it is. There's one strange thing on this joystick module, and it's these unpopulated pads on the top, and they're labelled R5, so you would think that that's a resistor, and my initial thought was that that must be a pads for a resistor for the switch. However, if I select a pad and take the outside pad and go to 5 volts pin, okay, there's a connection. So now you would assume that the other pad is going to go to the switch. There's no connection. You find out that it actually goes to ground. So that doesn't really make much sense to me. I don't know why you would want an extra resistor between ground and the 5 volts. It's just going to be an extra load wasting power that you really can't afford to be losing. So maybe you could put some sort of suppression capacitor over there to try and minimize noise on the power lines at the joystick, but yeah, I don't really know what these pads are for. So if anyone has a suggestion or actually knows what they're for, please leave a comment and let us know. Okay, so we have wired this up slightly unconventionally. So the blue wire is the ground, the white wire is plus 5 volts. The two black wires are the two signal wires from the potentiometers, and the red wire is our switch. So on the board here I have the switch wire, and as was in this diagram, I have a 10k resistor here. So this 10k resistor is going from the switch wire, so the signal wire in the switch, to the 5 volt line over there. And we have it on, so I have a mistake. It's actually going to ground. So now it should be on 5 volts. Okay, so there's our 5 volts. So if I hook this up to the signal, so we are now connected here to the signal here, and as you would expect, we have our 5 volts. We've lost a bit over our resistor, as you would expect, and if I close the switch now, it should go to 0 volts. There you go. So we went from high to low signal there. So in our Arduino, we would have it in our loop that it tests for a low. So high is normal. We flick the switch, Arduino sees that it's a low, and it does whatever you want it to do when the switch is depressed. Okay. So now that our switch is working, so let us check our axes. So here's first axis, which is the x-axis. It's not actually labelled on the board here, so the output here is the x-axis. So let's find out which it is. No, this is clearly the y-axis. So I better put it this way to be kind of more conventional. That's the x-axis, or that's the y-axis there. So this should be the x-axis. Okay. So you see in the central position we have 2.5 volts, exactly in the middle of our voltage range, exactly what we want. And as we move over, voltage is going down until we have 0 volts. Move to the left, voltage goes up to 5 volts. So with our Arduino, we will measure this voltage and control our device depending on what this voltage is. So let's just check the y-axis to make sure it's working as well. Switch over. Okay, so it should be our y-axis here. We go 5 volts and 0 volts short circuit. So that appears to be working perfectly as well. Okay, so here's the final product. We've made it up on a little board, and this is the beauty of these kind of little boards that you can get from IC stations. This took me about 10 or 15 minutes just to wire this up onto this little board, and it's a pretty good controller. Like that's a good feel there. And you know, if you were after spending hours building a model, like this Scania took weeks of weekends to build, and when I had it finished I couldn't really test it because I had no controller, and at the time I didn't have these little boards, so I couldn't just simply do this. I had to go through the hassle of soldering it all up. I had a couple of these joysticks, but they weren't mounted on these handy little boards. So this took me, like I said, 10-15 minutes to build this. When I made the other one, it could have took me a couple of hours, and that was a couple of hours waiting just to see if the lorry actually worked. So if you get yourself a couple of these little joystick boards, or a couple of switches, your Arduino obviously, and XP breakout boards and all this sort of thing, you can get most of this stuff on icstations.com, so make sure and check them out, because this seems to be working pretty good so far. So what I've done here is wired up our joystick here with the joystick to control the direction of the lorry, and the switch to turn on and off the lights. And the code for this, I'll be updating all of this into a blog post on the RC Tractors blog. So if you check out the blog post, you'll be able to get the code for this. So if you get all this stuff, you can just throw the code on and away you go, pretty quick. So I'll just show you it working. So this is our lorry. I think the battery's going a bit low on the lorry, but we've pretty fine control there. Very good speed control from our very simple joystick. And if I get us around, there's our switch. So there's our switch. No problem. Go forward, reverse. I get to see the. You can see the wheels there. Okay, if you're looking on the wheels, there's a steering left, steering right. So left, right. So it works perfectly. It's very quick. So I'm very impressed with this little breakout board. Simply because of how simple and quick it is to get working. So thanks to IC Stations for sending us these products to review, and if anyone has any questions or any suggestions, please post them on YouTube here or in the forum or on the blog. And when you see the code on the blog, if any of you happen to be Arduino experts and you can suggest improvements to the code, I'd be very happy to have them, and we'll share them on the forum, on the blog, and hopefully everyone will benefit from these videos. That's everything for now. I'm going to work on the next video. You've seen the LCD breakout board on the mailbag. He'll be the next, and I hope to build on this with the other breakout board. Just one last thing: if there was two joysticks here, you'd have fantastic control. You could have control for say an excavator. It'd be very handy. You'd need maybe a third joystick for your tracks, but you know, if you can picture that, how simple it would be to make a controller for excavator very quickly. Okay, so that's everything. Thanks very much for watching, and I hope you found it interesting. Let us know in the comments if you did. Thanks.